comets, the cosmic destroyers. Could they also be the reason for our existence and, more crucially, the cause of our extinction? Could they be the ones to deliver not only the essential water to our planet, but also the organic chemicals that sparked the creation of life? These celestial bodies may hold the key to understanding the origins of life and the universe itself. What secrets are hidden inside those cosmic time capsules? In 1994, a comet known as Shoemaker-Levy 9 flew too close to Jupiter. Scientists observed the planet's immense gravity tearing the comet apart before it collided with the gas giant. Many believed that Jupiter, with its massive atmosphere, would easily slow the comet down. However, each impact released more energy than our nuclear arsenal combined, even though this was a relatively small and low-density comet. The explosions were significantly less powerful than most comets can unleash. Yet they left visible dark scars on Jupiter's surface, a terrifying reminder of the power that comets hold. Witnessing this event firsthand made us realize that a comet strike could occur at any moment, and that it could happen on Earth. The average comet strike has the potential to set our planet's development back billions of years, melting the surface and ejecting debris into the atmosphere. This could lead to molten rock raining down across the globe. A comet strike can obliterate all life from the surface, but scientists now believe they are more than just doomsday rocks. Could comets also play a vital role in our existence? 4.5 billion years ago, our solar system was born. Gas and dust, heated by gravity, ignited our sun, while the debris surrounding it began to cluster together through gravitational attraction, forming our planets. However, not all the gas, dust, and material became part of these celestial bodies. Many remnants have continued to orbit the Sun for 4.5 billion years, remaining almost unchanged. If we could crack them open, we would glimpse the early days of our solar system's journey. Some comets still orbit beyond Neptune in a region known as the Kuiper Belt. Yet many others are even farther from the Sun, forming a vast sphere around our solar system called the Oort cloud. More than 1 trillion comets orbit our Sun, with orbits that can take millions of years to complete. In this distant realm, where massive objects like our inner planets exert little influence, their motion can be almost imperceptible. However, this tranquility is not permanent. A single collision between comets or the close approach of other stars can disrupt their orbits. Even our solar system's movement into a more crowded region of the galaxy can trigger a chain reaction, much like a peaceful mountain that can be set in motion by a single small step or a gust of wind, resulting in a devastating avalanche. Similarly, a once quiet comet could begin to fall from the farthest edges of our solar system, accelerating with each moment as it spirals toward the Sun, drawn inexorably into the heart of our solar system. On their journey, comets may encounter the immense gravity of the gas giants, which can either eject them completely from our solar system or lead to a collision on their way to the Sun. Those comets that continue their journey toward the Sun undergo a spectacular cosmic transformation. A cold, grey, icy and dirty piece of rock begins to change as it races past Jupiter. The Sun's heat starts to exert its influence on the icy nucleus, causing frozen gases to vaporize. This process releases grains of ice and dust particles, creating a cloud of material around the comet known as a coma. It is this coma that forms the beautiful tail of the comet. As the comet approaches the Sun, it becomes increasingly affected by solar winds, forming a second tail. While the comet itself may be only a few miles across, the coma surrounding it can extend thousands or even tens of thousands of miles. The comet's tail can stretch for millions or even tens of millions of miles. As the comet speeds up, reaching velocities of up to 50,000 miles per hour, it eventually approaches the region between the orbits of Mars and Jupiter, where the ice begins to melt and vaporize. The surface of the comet starts to quake violently, and jets of ice, water and gas burst forth from within, cracking the surface open and launching debris in every direction. These jets act like missile thrusters, pushing the comet in multiple directions and making it unstable and unpredictable. This violent stage can be the end for many comets, as their coma expands to enormous sizes, sometimes larger than Jupiter itself, with tails that can stretch 100 million miles. The debris left behind is composed of material from the very beginning of our solar system, allowing us to study these comets and learn about our origins. What we've discovered is that comets are far stranger than we once thought. While scientists initially expected comets to be uniform, we have learned that each one possesses its unique history and characteristics. In 2005, the Tempel 1 comet provided us with a deeper understanding of these celestial bodies. A NASA probe deliberately crashed a projectile into the comet's surface, creating a crater 150 yards wide. This incredible mission allowed us to peer into a comet for the first time, followed by other flyby missions and eventually the Rosetta mission, which revealed treasures inside these comets such as rubies, peridot, gold, diamonds, and various other gemstones. These icy rocks are not just time capsules, they are treasure chests. However, the true treasure lies in the variety of organic molecules discovered, which are the essential building blocks of life itself. The source of water on our planet has long been believed to have arrived from icy comets over billions of years. However, recent discoveries suggest that these comets may have contributed far more to Earth than we previously thought. We once believed that life originated from a combination of water, volcanic eruptions, and lightning strikes occurring on Earth itself. However, a new theory suggests that Earth is essentially a space rock, similar to the Moon, with comets playing a crucial role not only in supplying our water and atmosphere, but also in the emergence of life itself. Comets may hold the key to transforming our planet into the vibrant blue paradise we recognize today. The journey of these comets might very well be the reason we are here at all. As a comet continues its journey closer to the Sun, surpassing the orbit of Earth, its speed can reach an astonishing 100,000 miles per hour. As it approaches the Sun, it loses mass at an alarming rate, shedding as much as 50 tons of ice and gas every second. The comet becomes increasingly unstable, on the brink of breaking apart into fragments at any moment. When comets reach their closest point to the Sun, many meet their end, with some diving straight into the Sun and vaporizing in a brilliant display. This dramatic conclusion marks the end of their long journey and serves as a testament to the forces at play in our solar system. However, even the comets that survive their closest approach to the Sun are not entirely safe. In October 2007, while making its journey back from the Sun, Comet Holmes underwent a remarkable outburst, brightening by over 500,000 times in just 24 to 48 hours. This dramatic change made it one of the brightest objects in the night sky at that time, allowing it to be seen with the naked eye. This extraordinary event was triggered by an explosion likely caused by the sublimation of carbon monoxide gas within the comet's nucleus. The resulting pressure exceeded the structural integrity of the comet, leading to this spectacular transformation. Its surrounding cloud expanded to a size larger than Jupiter in just a single day, unlike other comets which can take weeks or even months to display such changes. This was the first time we had observed anything like it. In fact, the comet's coma became so large that it surpassed the size of the Sun, making it the largest body in our solar system at that moment. However, this incredible spectacle marked the end for Comet Holmes, which blew apart in what was the largest cometary explosion ever recorded at that time. The comets that survive their violent journeys pay a significant price. They can lose thousands of tons of rock, ice, and gas along the way. As they move farther from the Sun, their comas gradually shrink and they revert to being small, icy bodies, albeit notably smaller than before. As they travel back into the outer reaches of the solar system on a new orbit, they still face the looming threat of gravitational encounters with planets and other celestial bodies. This ongoing journey is fraught with challenges, reminding us that the life of a comet is a constant battle against the forces of the solar system. Several comets have passed by Earth in the past and are expected to return in the future. Halley's Comet made its appearance on February 9, 1986 and is predicted to return for its closest approach on July 28, 2061. Similarly, Comet Pons-Brooks was last observed in June 2024, with its next return anticipated in approximately 70 years, when it will reach its next perihelion around 2094. These celestial visitors remind us of the dynamic nature of our solar system and the exciting astronomical events that await us in the years to come. Most comets remain nearly motionless at the far edge of our solar system, far from any planets or significant gravitational influences. But what if something massive lurks beyond Neptune? Some scientists hypothesize that there could be a ninth planet out there, one with 10 times the mass of Earth, exerting its gravitational pull on the comets in the Kuiper belt. Could a super-Earth be hiding in the shadows, waiting to be discovered? To explore this intriguing possibility, watch the next video. And for a scenario of comet collisions with the Moon, click on the video below.